what we're kind
Yeah, but there was the deeper question of like, should we even do this? Like, I heard some people saying like, why are we supporting brownfield at all? And like, I think we need to address that. Um,
fair question. Yeah, yeah.
because
Let's
because
go
because
with
I
it.
my opinion is you have to support it. Like, we can't just say nope, that's out of scope. But uh, but it does raise a bunch of very thorny problems.
True,
Let me
true.
rephrase that. Should we support it in Cozy 1.0?
So how do you think the first set of users are going to use Cozy? Um, they're going to have a bunch of. I mean, currently people who are using buckets are probably going to be the early adopters. Um, and so far, everyone's been using, creating buckets outside of Cozy, obviously. And let's say we ask them, or one of the vendors asked them to start trying Cozy out. They're going to want to see how they can use existing buckets with Cozy, aren't they?
Well, okay, there's two questions embedded in there because the brownfield means both the case you just outlined, Sid,
Mm-hmm.
of like, I created a bucket outside of Cozy and now I want to use it in Kubernetes
Mm-hmm.
using the Cozy mechanism.
Mm-hmm.
But the other reason we talked about it at length is like sharing, right?
Mm-hmm.
If our model for ordinary bucket
Can
provisioning is what you create a BR and you get all this stuff, but you're stuck in one namespace
Mm-hmm.
and you can never access it from another namespace, which is the same. That's how PVCs work, right? You create a PVC, no one in any other namespace will ever see that PVC unless you do something very unnatural.
Mm-hmm.
Um, but so yeah, there's the question of what do we do about the
So,
buckets that were created outside of Cozy, and then there's the question of how do you deal with people in different namespaces who want to share a bucket. And based on our earlier discussions, those converged into one solution. They don't have to be; they could be two solutions. But we
right,
had been looking at those as
one.
one solution that would address
I
both of
agree.
those use cases.
I was actually thinking that yesterday. Yeah, it doesn't have to be one solution. So here's the thing. What do we do about PVCs with um, multi-read write mode, where you can mount it like NFS volumes,
Hmm.
where you can mount it in multiple places,
Yeah,
and
you
have them
can
all
have
read write.
as many pods as you want. They're all attaching to that PVC,
Mm-hmm.
but they have to be in the same namespace.
All the pods.
Yeah,
Ah, I see. Okay.
that, that's the idea. Is read write many gives you more than one pod at one time, but because it's still a namespace object, you still can't share it across namespaces unless you do something unnatural. I mean, I want to emphasize there are tricks you can play to get around this, but they're totally unsupported.
Okay, let me ask you this. So, are there any resources in Kubernetes where um, we have a bunch of namespace objects? Not so. I think by using the word bind, we're making things complicated. There is a reason for PVCs and PVs to bind, but I don't know if the same reason applies for bucket requests and buckets. Um, the
The
reason I go ahead.
go ahead.
Oh, the reason I bring it up is, say for example, you look at pods and nodes. Pods are namespace objects which use nodes. Um, I mean, if we were to consider buckets and bucket requests that way, where creating a bucket is different from, I mean, we already kind of have it like that. Creating a bucket is different from using a bucket. When you use a bucket, there's no real binding on the bucket back to the bucket access request. And creating is a completely external process. Um, if what if we were to consider it that way?
You're talking about a complete reconsideration of the Kubernetes API.
Look, I'm coming more from so it sounds like a big change, but this philosophical question needs to be asked
No, no,
because
no.
it's
I mean, I agree, but like, I we did ask it and we did answer it, and I just don't remember the answer. So now I'm trying to think like,
I don't know if we
there's
did actually. But yeah, what was the answer? If anyone can remember.
so the idea was when you're doing this dynamic provisioning, the, a user is going to make a request, and then a controller is going to see that request, and respond to it by creating an actual object. And then and you need to be able to delete it by deleting that object, and the controller sees the deletion request and then deletes it. And the problem is if you do that all with just the namespace object, trying to remember what the issues that arise are.
What I'm saying is, right now the whole problem comes from it's not even a big rework actually. It's a tiny change if you think about how to implement this. All I'm saying is maybe bucket request shouldn't be namespaced.
Bucket request shouldn't be namespaced. Okay.
But then all of a sudden you need cluster roles and cluster role bindings for application developers who sit in a namespace to be able to provision a bucket.
Well,
I'm saying
it's worse. It's worse than
Hey,
that.
is anyone sharing anything? Are we just talking
No,
like
we're
this?
just talking.
Okay.
We're talking about the brownfield case, or all of the API considerations around allowed namespaces in brownfield. So the issue with making them non-namespace is you don't know who owns what. Like,
No, buckets are always owned by. Sorry, what does that mean?
you just said bucket requests are not namespaced in this proposal, right?
Or why is there any concept of ownership like that? That part I don't understand.
Well, if Alice and Bob don't trust each other and Alice wants to create a bucket, how does she prevent Bob from deleting her bucket?
I mean, so that problem still exists today.
Well, but RBAC solves it if everything's namespaced, right? If Alice is only allowed to see Alice's namespace and Bob's only allowed to see Bob's namespace, then they can both happily create buckets in their own namespaces and they can never mess with each other's stuff.
So you're
Right?
saying buckets should be namespaced, or are you saying that
Bucket requests.
Okay, last we spoke, we RBAC didn't seem like a good approach because that's just one form of access control. Because you can't reasonably expect all customers to use RBAC, can we?
Yeah, I mean it's fundamental to Kubernetes. Like there's a lot of Kubernetes use cases, like the namespace as a service, where like you come in, you say, hey, I need a cluster to do some work on. They say, oh, here's a namespace in a Kubernetes cluster somewhere. Go nuts and go run your workload there. And
so you're
then
saying
that Kubernetes cluster can be shared amongst a bunch of users who don't trust each other because the namespace sandboxes you.
With the custom credential, sorry, with the custom admission controller, we can do that with the names cluster scope objects as well. We can do that RBAC.
How?
Wouldn't that be managed by the object store permissions? Outside of like,
No, we're talking about like when someone creates a bucket, who is allowed to delete that same bucket?
Or even access it.
Or even access it. So the namespace gives you a marker of where it is and who owns it, and then the Kubernetes RBAC system is naturally built around namespaces so that if Alice is in Alice's namespace, then she can't see the stuff that's in other people's namespaces and can't mess with it. So
okay. So there's one thing here. So I don't know if namespace is the right boundary, and when I say I don't know, I actually mean I don't know. It's not that I'm skeptical. So
so would you say then there has to be a mechanism then for the creator of the bucket to assign who's allowed to do what? To open it to brownfield, right? I mean, that's essentially what you're saying.
Yeah, if where you're going with this is like you want a kind of bucket that can be created at the cluster scope so that people in different namespaces can all see it. Like I think that's similar to the proposal that Tim was making for shared buckets. Like you just explicitly make the shared ones non-namespace. I think in his proposal you still had namespaced ones for the ones you didn't intend to share. And that model kind of works, but now you have like namespace buckets and non-namespace buckets. You have ordinary user buckets and cluster buckets is like two different kinds of buckets, right?
what was the issue with having just non-namespaced again? Like if you didn't have the namespaced buckets.
Well, if you don't have there's still the question of who has access. So I think if you go with if you went with Tim's proposal, if you have user buckets in the namespaces and cluster buckets that are non-namespaced, then in order to do anything with clustered buckets, you need cluster roles. And and ordinary users wouldn't be expected to have those. So then the ability to manage the shared buckets would require elevated privileges
Wait, hold
compared to
on.
what a
No,
typical user
we
would
could
have.
you could have a namespace selector kind of field in there that would work very well there. Like when you create the bucket, you put a namespace selector in there, and all namespaces with that selector is allowed to, you know, or you can just have allowed namespaces there, just a list of namespaces.
Yeah, but he's saying you wouldn't be from within a namespace unless you had elevated permissions. You wouldn't be able to create that bucket.
Yeah,
Which
yeah,
might
you
be
would
okay.
need create permission on the clustered resource and update and delete and all the other ones. And it's not clear to me that even if you tried to encode some sort of a ACLs into the clustered bucket, like I don't know who's going to deny the delete call when it comes in. Like the RBAC system is going to say, oh, your role is allowed to delete these things. Okay, it's deleted. Like who's going to veto that delete request if it comes from somebody else who's not supposed to be able to delete it?
I mean, that problem exists with PVs anyways. Like it's
Well, right,
assumed that
but you have to have elevated privileges. So in the model of, you know, it's a clustered object, you need the clustered role, and the idea is most users should not have the clustered role because it.
no, agreed. Let me ask another philosophical question. I guess I don't know. Maybe a user question. Should a user even be requesting buckets and deleting them? Maybe they should only be using them.
Well, that's the big part of the value prop of Cozy is that we create buckets, you know, in an automated way
We still do it. It's
for
just
ordinary users.
admin driven. Okay, yeah, that's the question. Do ordinary users need to create buckets? Like, imagine a world where they didn't.
Well, I mean, so in the very old days of Kubernetes, this is how volumes worked, right? The way no one could create volumes except for the admin. And people thought that was a terrible state of affairs. So we invented these dynamic provisioners where you just asked for storage and it was given to you automatically by the system, because people hated, you know, where all the volumes were statically created by the admin. And I think we'll quickly end up there with buckets. If we try to go with a system where all the buckets have to be created by the admin, people will say that this is okay, but I would prefer a dynamic bucket provisioner that makes me buckets when I ask for them.
So
we'll end up right back where we started.
Okay,
so
go ahead, Aaron.
I was thinking, to solve this, why not only brownfield buckets are at the cluster level, but and greenfield are at the namespace level for version 1, right? If you need a brownfield bucket, then it has to be done at the cluster level.
Yeah. The only complexity of that is this is similar to what Tim was proposing.
Yeah.
Yeah.
Or we just don't do brownfield in version 1 and we move on. Just let's get done.
We need to separate that out into, you know, pre-existing buckets and bucket sharing across namespaces. Which one of those two things do we not do, or do we not do either of them?
I think there's a fundamental flaw in this whole idea of sharing being a complicated thing. I think we're applying too much of the block and file system semantics here, because buckets inherently are easier to share. It's just a URL and credentials. So,
well, hold on. The bucket is easy to share, but the credentials are something that we've said should be created dynamically.
Right. So credentials are unique to each user, right?
Yeah. So you don't share the credentials. You get your own credentials.
So as part of the bucket creation, you put on a policy on the bucket with access permissions, and that solves the delete issue.
who do we put? Do we put a Kubernetes user in there, or do we put a object storage user in there? What do we put in there?
You put a list of namespaces in there.
Well, it'd be the object store. Well, on a bucket, it would be the object store user. It'd be the user tied to those credentials.
How would someone assume the role of that object storage user?
Yeah,
how would a pod assume that role?
The model we've had up until now is that, you know, when you create a bucket, it doesn't have any credentials, and then you ask for Kubernetes to create you credentials, and we do that dynamically so that every user can get their own credentials, or more than one set of credentials if they have more than one workload and they want to have them access the bucket with different levels of permission.
So why can't that update the bucket policy when it creates new credentials and allow access to those new credentials.
It can, but there needs to be a way to deny some requests that are, you know,
By
to
default,
decide which requests are allowed or not.
by default though, it's deny all, right?
Yeah. Well, yeah. So an allowed namespaces list on that clustered object that was empty could imply that no one's allowed to do anything, and then yeah, you add some namespaces to it, and then those guys are allowed to do things. That would be a way to do it.
Okay, so the whole reason we even started this discussion was because one, allowed namespaces is it's kind of weird because you know if I have a new namespace that I add later on, I can't use that bucket until an admin intervenes.
But you could have a wildcard if you really wanted
Yes.
wildcard semantics, right?
And
Like
then
you could say the empty list means everyone, or you could say there's a special flag that you put on it that means everyone.
why do we not have wildcards anywhere else in Kubernetes? I think that's going to be worse.
Yeah, I'm not arguing for wildcard. I'm saying, you know,
Okay.
something that semantically means everything.
Omitted
I
to mean
still-
everything, like you said, Ben. I may have, I had a short interruption, Ben, but I wanted to get back to your point, unless you've already discussed it, about controlling delete access. Because allowed namespace is just saying any request, any request, any BAR in this namespace is allowed. But can anyone delete a bucket? If BR1 creates a new bucket, and then there's some BARs that reference the bucket outside of BR1's namespace. So we're now in a different namespace. I reference the B directly in my BAR. And I'm allowed. Can I delete that bucket?
So Jeff, I was talking about this in the context of the BR or whatever we replace BR with is a clustered object. Right, that's what Sid had been suggesting, and I was saying in that world, then the RBAC system requires you to have access to the clustered object to create them and to delete them, and that's an elevated privilege. And so in that world, if that's all you give people, then ordinary users can never create or delete buckets. And to the response that, you know, well, let's just give everyone access to it. Then the issue with that is, well, then anyone can delete anyone else's buckets, which doesn't make sense.
No, that's not going to be acceptable, right?
Right. So I think if we have some sort of a clustered object, then the answer is only someone with elevated privileges can manage the clustered ones, right? If there's a shared clustered bucket object that can be seen by multiple namespaces, then only an admin can create that, and only an admin can delete it, or someone who has a special role for managing those kinds of things.
It's really who has, if you ignore deleting clusters, with our current model, with BR's namespaced and BAR's namespaced, the bucket delete is triggered by the deletion of a BR under normal circumstances, right? And who can delete the BR? It should only be someone in that namespace. So the issue really is within a name, and this is what Sid was getting at, is namespace the wrong boundary? But Kubernetes, that's the most granular we get, I think. But
RBAC.
Well, Tim's suggestion had been do both. Have the namespace ones so that ordinary unprivileged users can create and delete buckets that are only usable in that one namespace, but also have a clustered version of them that allows someone with elevated privileges to create and delete buckets that can be seen by more than one namespace. And it feels like a workable model. I mean, it has more objects in it, which is something we'd have to think about, but it's not a crazy way to do it. The specific, well, okay. My concern with that is it still doesn't help you with, you know, what happens when I want to share across clusters, right? That sharing across namespaces is addressed by just make a clustered object and then everyone can see it. Sharing across clusters is not addressed that way. You have to do something in the different clusters. And my preference had been to say, well, let's not create any clustered objects. Let's make everything namespaced, and then, you know, just accept that whatever mechanism works for sharing cross cluster will also work for cross namespace.
right.
and that felt better to me. But I don't have a, that's not a deal breaker. It just,
Yeah,
I
what
like
if,
that model.
actually,
The other thing that Tim brought up, which I think Sid is hinting at again, is
Mhm.
do we need the BRB split, and do we need the BAR-BA split? Do we need to have the namespaced object paired with a non-namespaced object and have them get bound? I think Tim was suggesting maybe not, and Sid seems to be suggesting once again maybe not, and that makes me really nervous, but I can't put my finger on why. So,
Yeah,
I
yeah,
think
no,
that's a fair statement, Ben, of not, I think they tried to do that with one of their networking caps.
gateways, yeah.
Um,
The-
and where the user side of things is the declarative spec portion, say, of a BR, and then status is what Cozy adds in. That could be basically the B. In the BR-B pair, you know, the BR is BR.spec is declarative user stuff, and BR.status is Cozy bucket instance stuff. I think if I understood what Tim was saying, and he wasn't
yeah, I'm,
100% committed to that idea, but he was liking it.
so
yeah, I
I'll
mean,
tell you, where I was coming from when I suggested it. It's coming from this idea that we're not really binding to a bucket, we're just using it. There is a difference between, using and binding. Binding almost implies that you're reserving it in a sense. And we kind of follow those semantics when we talk about adding these finalizers and references back to the bucket access requests or bucket requests that created the bucket. That being said, when I think more about it, it was just a suggestion, but when I think more about it, there do seem to be issues there. I want to quickly visit what Ben was just suggesting. What if we said it's all only namespaced, and if a second namespace wants to use the bucket, they can go ahead and create the bucket again, and if it's an existing bucket, they just get an existing bucket, um, instead of ending up creating a new one. Like, what if we said that?
But how do they do that, Sid? Because the name isn't even specified in the BR. We just have a prefix.
Maybe that's the change we need to bring in, but the idea is we don't have the concept of a clustered bucket whatsoever. It's always just namespaced.
yeah.
And
If Alice creates a namespace bucket in her own namespace, and then she decides she wants to share it with Bob, the scheme that we proposed a couple weeks back, or maybe it's months at this point, was that she could go find the name of the bucket after it's bound and share that with Bob, and then Bob could create his BARs and point them directly at Alice's bucket, and then Bob would never need his own BR because
Correct.
the bucket already exists, right? Or there was another scheme where you do create the BR, but you somehow point it at the other BR. You get a copy of the bucket, and then you point it at that. I mean, various things you can do it.
That's what I was hinting at. The last one you just said.
Well, that
Copy
was
the bucket again.
cloning stuff, Sid, that I
Create
thought-
another version of the bucket. Yeah.
Yeah. So that is how snapshots work. If you want to share a snapshot across namespaces, you have no choice but to clone the volume snapshot content object and then create another volume snapshot in another namespace and bind it to the clone of the volume snapshot content. That works today. It's fine. But it leads to this bizarre situation where you have two volume snapshot contents that point to the same physical thing, and either one of them can delete it. And of course, you can use deletion policy to stay out of trouble. But you have to be, it puts rope in the user's hands that they can trip over or hang himself with.
I mean, when we share it, it'll be us who's sharing it. Like, we're the ones that build the sharing semantics. We could always say, even if there's one other copy of a bucket, we're not going to delete it. We're not going to delete the backend.
I mean, but that
Something
doesn't
like
work.
that, or a deletion policy can
again,
address it.
Cross-clustered, those kinds of solutions don't work. Like
Yeah. So
when you
I
go
mean,
cross-cluster, all you have is the deletion policy, and it has to be set correctly. And if it's not, it's going to blow up.
what if we rely on the what if we rely on the backend somehow?
What does that mean?
Can we ask the backend delete this when all accesses are done?
How would the backend track all accesses.
Okay, so I mean the backend might have the ability to do that, but yeah, I'm
We're
not sure
talking
at this
about
point.
two entirely separate Kubernetes clusters with two instances of the cozy driver
Oh
pointed
no.
at some S3 object store
Mm-hmm.
where they both are seeing the same bucket, right? Like
Yeah.
they can't talk to each other. There's no means of communication. They both have a reference to the same bucket, and they both have to mutually agree not to delete the bucket.
No, the S3 object store could has to know about the accessors because the credentials are being created by it. But no, I'm this probably not
No,
gonna work.
it
Mhm.
doesn't, because you could have no accessors at that moment, but still have references to the bucket, right?
Action is
Because because it, as long as you have a bucket, you're reserving the right to create accessors in the future. But if someone deletes the bucket out from under you,
Yeah, but if nobody's accessing it right now, you can delete it from under them. There's no.
but but that's not how it's supposed to work, right?
No, I
It should
agree.
be it should be legal to have a bucket with no one allowed to access it right now, because tomorrow you're going to give everyone access.
No, we're talking about when to delete, right? That's the in that sense.
So
Yeah. So no, I do see the problem with this approach. Like I wasn't sure where I was going with this whole. Can we rely on the back end? But what if we didn't even have like why can't we address this just with deletion policy, where you have multiple copies of the bucket? Like
But
how do
no,
you address these
you,
snapshots?
you can, and it's just I just wanted to point out that you have to set the deletion policy right, or you get strange behavior. So this is the decision that was made with snapshots, and I'm living with it right now. It's
How bad is
okay.
it? Like,
It's fine. You have to set the deletion policy right.
do you
And if
have
some
anyone like accidentally deleting snapshots, losing data?
no, because every time we would clone one of these VSCs, we put deletion policy retain on it always. And the bigger problem is when you're always creating your VSCs with deletion policy of retain, you can end up in a situation where nobody's able to delete it because all of your copies say retain. And then you have the reverse problem of, you can delete all of your references to an object without deleting the object itself. And now it becomes garbage floating out there that you're paying for and you can't delete. And that's a separate problem. But
That's a better
yeah.
problem to have than losing data and dealing with
Oh
that.
yeah. I mean, I'm saying like this is the best that we have today, and it's still annoying, but it's livable.
To be honest, that seems like a cleaner model. Like I think the risk of I think the risk of having a more complex system is greater than having a system where it's harder to delete. Like the way we have it right now, even to us, it's not very clear how we're going to do sharing. But with this idea where buckets are namespaced, this problem won't exist.
Yeah, but you'll also recall from our prior conversations that if we ever want to get into the bucket mutation business, you'll have all of the same problems amplified even larger, right? And that's when we started talking about when you're going to need a mutation policy that says whether, if you have multiple sources of truth, which one to listen to. And we didn't like that. And unfortunately, we don't have any proposals to do actual bucket mutation on the table, but we feel like it's something we could have someday. And we were trying to figure out if there's a way that we could avoid having the same problem as deletion, but with mutation, where you have to figure out which one is allowed to enact changes on the actual bucket when you have multiple of them.
This is why
Well, should those namespace buckets be the same? Can't there be like one canonical bucket, which is the first one that gets created, and then the clones
we've
become
talked about this before.
Yeah. This is where we had eventually landed before we went into the mode where we were trying to get the KEP approved. We started focusing on other things. We had this idea where instead of cloning the B, we could just share it across namespaces by having other BARs directly reference the B, and then you only ever need one per cluster. You still need a second one if you go to a second cluster, but at that point,
I mean, then
well,
cross cluster still doesn't get resolved in that case.
no, right. And if you ever want to do mutation, you're screwed in that case. So
So
And
what kind of mutation do you
cross-cluster,
need? So what kind of mutation do you need?
Oh, I don't know. I mean, any hypothetical property that the cozy controller might want to set on the bucket that can have more than one value, right?
What if bucket properties were a status field and they were back populated?
It still doesn't help with, you know, when you want to mutate it. I don't know. Let's invent a hypothetical property like encryption true false.
Yeah. So let's say you have a bucket. Okay, so you don't mutate it through the bucket object. Let's say you mutate it through a bucket. Just like you create a bucket through a bucket request, you mutate it by, say, you're using a bucket mutation request, and all the buckets
Oh.
get updated values. Throwing it out there.
Okay, but that's not that's an imperative API style, not a declarative API style. Right? In a declarative API, you already have your bucket. It already has a value for encryption, and you just want to change it. In
No, it's
theory,
not really imperative, right? Because you're defining what the mutation should be. Oh, I get. Yeah,
but
it's still
it,
declarative.
it's a question of desired state versus like do this now, right?
No, you're saying, okay, so bucket mutation request would show the new state, not, it wouldn't show what's the, if you're in this state, go there.
And
You
then
know what
all
I
the
mean?
buckets just see the
The controller would
new
see that
state.
and then take care of updating the bucket and then back populating it into the bucket object.
Right, but for how long?
I mean, I don't
Like
understand the question.
when I create this bucket mutation request and then with the mutation is enacted, does the object hang around? Do I delete it? Like, what do I do next?
Mark it as, it's like certificate signing request.
So it gets marked as done and then I never look at it again?
Yeah, maybe.
Because now it's in the properties of the bucket.
Right, but if someone else then flips it back, like
All the
I
buckets get
allow
updated
that.
again.
Right. All the buckets would get updated, but the mutation request is marked as done, and it doesn't try to assert itself again.
Right.
So that's
They're
kind of
not
imperative,
receiving-
right? It's like a one shot, right? It's change this value from false to true, and then once it's true, I don't care what happens after that, right? And
Well, because then if you wanted to change it again, you'd have to kill that and then create a new one.
right,
Yeah.
but I mean, but that's an imperative API style, right? It's like do this now, and then once it's done, you know, there's nothing else to do. The declarative APIs are, I want it to be in this state and I want it to stay in this state. And if it changes, put it back in this state, right? It's an expression of the desired state, which is constantly reconciled.
yep. And the certificates API doesn't apply here because that one is linear. It moves forward until a certain point and then it stops. Well, enabling this encryption, disabling encryption again is you can flap those values. So you
Yeah,
run
I
into
mean,
concurrency issues.
Well, no, that's, yeah. So what if we made it a singleton, Ben? Per bucket, you can have only one mutation request.
I don't know. I've never seen an API in Kubernetes where we did like, you know, an imperative style, you create an object to make a change and then the object becomes defunct after the change is made. I've just never, I mean, maybe certificate requests are the exception.
Yeah, but
because,
certificates can only be signed once. You can't unsign them.
Yeah, it stops. It's a workflow.
yeah, I mean, so certificates are a special case, clearly.
But changing bucket properties would be the same. Like you would change them.
No,
You
I
don't
mean,
expect
like
that.
if you created two bucket mutation requests for the same bucket, depending on the order, you might end up with different results. Oh, someone
Yeah.
said jobs. Can you explain that a little bit more, Ricardo?
Yeah, jobs they get defunct after created, right? So you have a controller that remove them
Once it's
later.
defunct, you can't rerun the job. It's again one shot and then, you know what I mean?
Yeah,
Yeah,
but jobs are interesting because a job is a way to sort of run a pod and then rerun it, you know, if it fails. And so it's like it's a nice wrapper for pods to sort of keep trying until you reach some terminal state. And so having a tracking object around to sort of pay attention to the pods is useful. And then yeah, it reaches some terminal state. But like two jobs can never interfere with each other.
Mm-hmm.
Like two mutation requests clearly can, because they're referring to something to be mutated.
But are we really trying to control an external resource which can be shared between clusters just by having some state in the one cluster? It doesn't really
No,
like,
no,
it
that's not
doesn't
what
add up, right?
No,
Well,
that's not what we're doing, guy. We're trying to keep the state local to the cluster, and we're saying that for namespaces also. We're saying buckets are also namespace. So anything you do to the bucket is or when using the bucket, you're only using the local bucket. Whether you're using it from a different cluster where you use it within namespace, or whether you're using it within the same cluster but in different namespaces. Each namespace gets its own copy of the bucket.
So the closest analog we have, I think, is resizing a PVC, because PVCs have this size property, and if when you create a PVC, you specify the minimum size, and then if you later change your mind about it, you can increase that value. I don't think buckets have a concept of a size, but you could imagine a scenario where they did, and then the problem you're going to run into when you're trying to share one of these buckets is that if one guy tries to resize it and the other guy doesn't, which size is correct?
It's true to any property. It's true to any property that, you know, it's just, we're trying to manage. I'm not talking about the bucket. When I said the earlier bucket, I didn't mean the bucket resource in Kubernetes. I meant the external bucket.
Yeah.
Right. If there's an external entity, say whatever, it can be in, you know, a virtual machine somewhere that you represent with a CR or a CRD. You know, if you want to share it between clusters, you cannot really synchronize this state in a way. Yeah.
That's exactly the, but we did believe that there are situations where, like, you want to create a bucket and then you'll want to be able to change something about the bucket you created, irrespective of any kind of sharing.
Well,
like,
so far we've been saying, you know, we don't do mutation, but that's not going to be practical in the long term, it looks like.
Right. So I'm saying with PVCs are in a situation where they're not shared. They're always just in one namespace. And so it's perfectly reasonable to say, you know, that 5 gig PVC, I want it to be 20 gigs. And for Kubernetes to go do that for you, it's a reasonable workflow, and we implemented it. It's extremely complicated, by the way, but it does work. And it partially works because you're not sharing it. So the question is, if we ever do want to allow end users who created buckets through Cozy to change things about those buckets also through Cozy, we have to be very careful about how that interacts with any kind of sharing. Because,
but what do you do with NFS? Like with NFS shared between namespaces or between clusters?
You don't. I
mean, you don't have shared file systems between clusters, or I mean, shared volumes.
Not with CSI. Like you can create outside of Kubernetes an NFS share using whatever you want, and then go and create NFS PVs on 2 different clusters and point them at that storage. But then an attempt to resize those won't go anywhere, because the NFS driver doesn't know how to resize. It just says, whatever. I don't know what to do with this. It just, NFS is an access only CSI driver. Like if you actually know that, like the NetApp Trident driver, which can give you an NFS volume, was never going to give you a volume that you can use on multiple clusters. You're only going to get a PV that's bound to one PVC on one cluster and one namespace through a traditional CSI driver.
Yeah. Well, this just sounds like a limitation of, you know, knowledge. It's the cluster doesn't know what it doesn't know. So
yeah.
I mean, if at all it's possible to, you know, make it, you know, cluster proof, it's not a bad idea. So the whole reason we discussed this whole backpopulating thing was, how do we do bucket mutation? Is there some other mechanism to do the same thing?
What are we mutating? What is the property that we are looking at?
Let's say we're turning on and turning off encryption. A bucket's been created, it's been shared across namespaces, and each namespace gets its own copy of the bucket. In this mechanism, let's say we want to turn on encryption. One approach we discussed was you have something called as a bucket mutation request that'll describe the final state, and once the controller mutates the bucket, all the buckets will get the updated copy of the current state. So all the buckets will have the state saying encryption is true. Now, we decided that's
But
not a good.
it doesn't change anything, right? It just makes the request ignorant to what happens after it's being processed. That's all it does, right? It explains to the caller, to the one creating the request, that after you get the status back saying it succeeded, you cannot know anything other than it once succeeded,
Right,
Yes.
right.
Yes.
right?
That's the problem.
So,
Yeah, that's
I mean,
exactly.
it doesn't change the property that these clusters don't have control of each other. They just control whatever the cluster controllers, can synchronize internally, but that's it.
Well,
So
yeah, and the final state is not represented by the bucket mutation request. It is imperative. I see what Ben was saying. So, is there a better approach? Is there a different way to do mutation?
The only other approach I could see would be to have like a mutation policy where if it's set to false, you basically ignore any specs for an existing bucket, and then if it's true, you apply the reconciler, you reconcile
it's
with
like
it. But
ownership. I would say
but
I
you
would
would
own a bucket, right?
right,
In
but you
one.
would need to have an ironclad guarantee that no more than one copy ever had the mutation policy set to true for a given bucket. Otherwise, the controllers would fight with each other, right?
That won't work across clusters.
Just like delete policy. I mean, it's the same, right?
Right,
It's
right.
it's the
It would work as long as you get the policy right. If you get the policy wrong, you get bad behavior. And it's
The user's fault at that point.
and it's more than that. It's also that whenever you start sharing, like you said before, when you start sharing, you cannot go back, right? It's not that you can now say, okay, now I'm owning it suddenly just because I feel like changing this property. You don't know what will happen because somebody else can decide the same thing. So we're not adding any synchronization mechanisms here. We're just allowing somebody to say, I am the owner, and that's it. I know what I'm doing, right?
Yeah.
Now I want to be able to reconcile this over and over. And if somebody's also thinking the same, we're going to fight over this resource external to the cluster, and no, and neither one of us can really know that we're thinking that with somebody else also doing that. But if somebody wants to just assume ownership, it can do that. That's what we're saying, right? It just allows us to somebody say, I'm the owner of that, whether it's through bucket creation, like bucket request, and then I say I created this bucket, so I own it, and I can change things about it, or by sharing a bucket and then saying, well, I'm the administrator of this environment. I know that this bucket should be owned somewhere, and I'm going to set the ownerships on this cluster.
right. That's my thinking, and it feels gross because you can screw it up, and then the results are bad. But I can't think of a scheme that is any less bad.
I don't think it can exist, right? In the assumptions that we're taking, like having just random clusters around the world, having no synchronization between them. It's like we're not giving ourselves any synchronization mechanism to do that. So
Well,
how could it exist?
The other stance we had is that we could say, well, we're just never ever going to do any kind of mutations of the buckets, and then stay out of this area. And that it's perfectly reasonable for like a 1.0, but it feels a little less reasonable for the long run.
We'll always have deletion, probably, right?
Yeah,
Just like we had, because just we had to have creation, so we probably have deletion. But you're saying maybe if we don't add mutation, we're gonna stay in the safe zone of what we know from other CRDs, from other entity resources in Kubernetes that do the same.
Yeah, the deletion policies are a thing that people understand. So I've never seen an actual mutation policy, although it's semantically identical to a deletion policy.
Yeah, I think it's just a matter of ownership. So if you assume you're the owner, you can delete and you can mutate, right? That's roughly where it is.
Yeah.
So I don't think
So,
mutations are a no-go.
So
hello, can you hear me?
oh yeah,
Yes.
please go ahead.
Oh, so sorry, this is Mauricio. It's my first time joining this meeting, and I was wondering if you have a document with the notes that we're taking about all of the things that we're talking about. Been listening to the multi-cluster problem that we have when we try to share an object, a bucket of them. So in this problem, I think that there is no source of truth. We would have two clusters, like two brains, and no one would be the owner. So I'm just going to throw an idea there. We could have a third-party place that could serve as the owner of the bucket. So one way of doing this is with a provisioner like Terraform. And what we could do is have one Kubernetes cluster that creates the bucket and updates its properties through Terraform, and the state will be stored in Terraform. Kubernetes would act just as a proxy to this Terraform state. And if we have multiple clusters, then all of them would go through Terraform. So the idea is just to have one single source of truth. I think that if we have multiple clusters, and it's kind of hard to decide who is the owner. If we have,
the issue is you in the very simple case where you're not sharing, you want the cluster to by itself create the bucket, make any changes to the bucket that are necessary, and then delete the bucket without having to consult anything external. For the simple case of it only ever existed in one user's namespace, but then you want to be able to migrate from the it only exists in one user's namespace to the it's not now it's shared across multiple namespaces, or now it's shared across multiple clusters. I mean, at least in principle, we've said that's something we want. I think it's still up for debate, whether you can move from the so-called greenfield case to the brownfield case, or whether, or to what degree we want to support brownfield buckets at all. That's where we started this meeting was, are we still
I think the
convinced
question is
that
if brownfield allows us to to do mutations or have ownership, like you can move between them if you drop your ownership. Clearly you can say I'm now, my deletion policy is now retained for everybody. That works, right?
Yeah.
But how do you go back, or how do you assume ownership back? That's currently something that you need somebody, a god mode for that. You can't really do that without somebody who knows everything.
Yes.
Okay, what if we said okay, so going back to the old question, okay, so what if we said for all buckets that you create, you have the ability to mutate or delete. For everyone that uses an existing bucket, again the greenfield brownfield dichotomy, you would still we still keep this dynamic of having a bucket per namespace, but for all those buckets that are requested, all those pre-created buckets that are requested, they just don't get the ability to mutate or delete. Just no. So then all of these problems go away, because you have deletion and mutation is handled in the namespace that created it. Everyone else just gets to use it. They don't get to change anything.
Sure. Yeah. I mean, that's the starting point. But then if the whole cluster that created it goes away, and the other clusters that now have references to it continue to have references to it.
Yeah, but that's a disaster scenario. An admin has to go manually delete it in that case, or manually update it in the backend.
Yeah. I mean, it's just
that could
pointing
be
out that like there's work to be done in that case. It's kind of nasty.
Right, we can put that in the documentation, but do we have to solve that problem for them?
I don't think we have to solve that in version 1.
Or ever, maybe.
or yeah, I mean, there in a disaster scenario, there's expected to be some manual intervention.
Right.
I think that's okay.
Yeah. That's where I'm coming from. It's a simple model, and sometimes simpler models are better.
Okay, so we're still happy with everything is namespaced, and sharing is done by creating copies of things in other namespaces. What about the proposal that we had a month or three back about, well, if you're just sharing across two namespaces in one cluster, you don't actually need to have a second BR and a second B. You can just point your BARs at the existing B. That was
You can do that across. I mean, like it's symmetric. It's simpler to just have the same mechanism no matter how you're using the bucket.
well, but we did convince ourselves that there was some advantage to this other scheme, and I'm trying to remember what it was. I think, but part of the problem is if
No,
Alice and
you
Bob
can
want
use
to
it.
collaborate
Mhm.
in the scheme where you need two Bs, neither Alice nor Bob can create the second B. You need an admin to come in and do it for you, or a controller to clone it with deletion policies set to false, and then give the name to Bob. If it's Alice's bucket.
Right.
With the scheme that we had proposed a couple months ago, where Alice just tells Bob the name of the B, then
Yeah, we could still
Bob
do that.
creates a BAR pointed directly at B, and now they can share it. If the B has Bob's namespace in the allowed namespaces. That was the other key, is somehow the allowed namespaces needs to get updated. But if that was done ahead of time, then you don't need an external controller or an admin to help you collaborate. You just need a copy of the bucket in the cluster where you are, and then you point your BAR at it. Of course, collaborating across clusters, it doesn't work. You still need someone to come in and
Exactly.
create that B.
Right. So, I mean, I think it's reasonable to say if you're going to share it across namespaces, someone needs to tell you the name of the bucket. It was created in a
Right.
different
But
namespace.
do you need to create another
Copy.
copy of it and another BR and bind them?
Well, you don't create another copy of the bucket. You create a new BR and point it to the bucket by a certain name.
No.
But that's the same. I mean, that's
That's a
just
many to
having
one
another.
binding, right?
No. So the controller will make a copy. So when
Oh,
you
I see what you're saying. You're saying
yeah.
that if I have a special BR mode where instead of saying give me an empty bucket, it says give me a copy of a bucket, and then
Give me a bucket by name. Yeah.
some controller responds to that by cloning the bucket and then binding me to the clone of it.
But what's the purpose of the bucket request in that sense? I mean, isn't it just bucket access request that I'm actually interested in, right? I'm just trying to figure out the intention behind having a BR in that flow. Why is the BAR not enough to describe that? Right. That's the only question in that case. Why do you need a BR? What does it
Create
do?
if it does not exist kind of semantics. So if I'm going to access a BAR, if I'm going to have a BAR that points to a bucket, and if the bucket or BR, sorry, so BARs first of all point to BRs, even though that can be changed. Here, the semantics is the BR should have created a bucket before the BAR can point to it. Well, if you had it the other way, where the BAR pointed to the bucket directly, then the bucket should have already existed. Because
Right. That had been the proposal a few months ago, was you could choose one or the other. The BR would be easy for the case when it was your BR, but you could point
But
to a bucket if it was someone else's, and they told you the name.
yeah, Tim's feedback to that was, why are we having two different mechanisms to do one thing?
Because it's not one thing; it's two things, right? One is a self-service model, and the other is a sharing model.
So how? Okay, so is that better than using another BR and having the BAR always pointing to the BR? So in that model, in the model that we had a few months back, we said either the BR points to a bucket or the BAR points to a bucket. Sorry, so either the BAR points to a BR or either the BAR points to the B.
Yeah, that's what we're saying is
Mhm.
in that model, you don't need a second BR because the BAR can point to either thing. And having a second BR would serve no purpose other than to
No, you need
simplify
it.
your BAR API.
No, you need it still. So that means, okay, so that means if I have a BAR pointing to a B, what would happen is, let's say let's say another accessor is trying to point to the same bucket. Um, since the bucket copy, the life cycle of the bucket copy is tied to the BAR, it gets kind of tricky, I think.
There's no copy though, Sid,
Yeah,
in that
in that
example.
world, you never have more than one bucket per cluster.
Right. You have a single source of truth from cozy perspective about the bucket. There's no clones.
Yeah.
The BAR adds a BA for you, right?
Correct.
Yes.
That's
Yes.
that's what
But how does
adds
it
for
how
the
does it
request.
point to the how does it point to the bucket in a different namespace?
It's
The
not a
bucket
namespace
is not
object.
namespace.
Right. I mean,
So wait,
Sid,
okay, I'm confused here. Maybe I'm thinking about, so we're past the approach where we have buckets being namespace. Is that where we are?
No,
No, no, no. The
buckets
bucket
have never
itself
been namespace.
reference back, right? But it references back. It bounds to the bucket request. It could be bound to bucket request, but it doesn't. But it doesn't mean that other bucket accesses cannot refer to it. That's the model where we're saying multiple bucket access objects can reference the one bucket, right, in the cluster.
But
That's a many-to-one as well.
Is the bucket cluster scoped?
Yes.
Bucket has always been
I don't
cluster
think we're-
scoped, and bucket request is namespaced.
I see. Okay, so we're back to that approach that we had like at the beginning of the meeting.
Well, no, I mean that's the approach we've had for a long time.
Right.
We can
We just
change
described
that.
it big again. Yeah.
Yeah, we can change that, but we need a good reason.
So okay, I'm a little confused. Did we resolve that whole issue? Like, we last we I think the last thing that I don't know if we resolved this. The question was if we had this approach of bucket per namespace, and we disallow mutation and deletion from any namespace where the bucket wasn't created. Where did we end up with that conversation?
Okay, so we agreed that would work, but the downside of it is, in order for Alice to share her bucket with Bob, somebody has to create another bucket and the non-namespaced object, the cluster object. We had a proposal on the table from a couple months back where instead of doing that, Bob just creates a BAR that points directly to Alice's B because she gave him the name, and Bob's namespace is on the allowed list for the bucket. And then that BAR can use the B directly without ever having a BR in Bob's namespace. And the benefit of that scheme is, aside from not having multiple buckets, which doesn't really add much, is just that no one needs to have permission to create that second bucket. So you can just more easily share a bucket across namespaces. That's the only benefit. But we had liked this scheme as of a couple months ago, before we were trying to get the KEP approved. This was our official stance, that brownfield sharing is done by just pointing your BAR directly at a pre-existing B. And that B didn't even have to be bound to anything, right? It could just have been floating out there, created by an admin, with no BR bound to it whatsoever.
Yeah, that was the stance like before this meeting started.
Yes. But in that world, you need access control, and therefore allowed namespaces has to be on that B, so that when Charlie comes in and tries to create a BAR pointed at Alice's B, the system can say, no, I'm not doing that, because you didn't share that bucket with Charlie, you only shared it with Bob.
But that'll be required even in case we do the sharing the other way, don't we? Where bucket is namespace scoped.
Yeah, I mean, yeah, you need some kind of security mechanism so the people who shouldn't be able to see it can't see it. And and up until now, allowed namespaces has been that thing.
So the whole conversation, okay, we're out of time. I think we should continue this on Monday. I think this was again a good discussion. I feel like last meeting, that is on last Monday when we discussed, we were closer to a solution for some reason. Let me go back. I'm going to go back and look at the recording, and see if there's something there. Um, I think today maybe it was worth it to go and revisit the old approaches, but we haven't yet decided on, today's discussion did not end up with a decision on how we're going to do this allowed namespaces. Um, so yeah, let's continue on Monday, and we'll continue the conversation. But we're definitely making progress. It was definitely good to go back and see where we were and why we didn't choose those things.
But we need to figure out if there's like something specific that we want to change, and then why we want to change it. Because
Right.
I feel like we've gone in a circle, but like let's not keep going in circles. Going in a circle once is okay, but we need
Allowed
to
Has
namespaces
terminate
anyone
the loop.
recorded like why we are making this decision, why we go with this alternative, not the others, and this way we can so that we avoid us from going into circles, that at least we can go back and see.
No, Tim's feedback was valuable. So what he said, and I agree with that, is allowed namespaces really isn't doing anything, and it's actually more confusing, because again the namespace has to exist, and if you want to create a new namespace that needs access, it gets tricky again. Um, so I don't know if allowed namespaces is the right approach. We need some way to tie it back to the user. That's where the
Sid,
discussion started. Mhm.
I just speaking my mind, I think at the beginning of the working on the caps, you had pretty good diagrams of these entities and captured the relationships with them. And maybe we can go back to just having like comparing
Yeah,
two diagrams, one versus the other,
I think that's a good
because it feels
solution.
like we're talking
I can do
like
that.
on the air,
Mhm.
And we should
hand
have a clear
waving. So
definition of what we're trying to build and what the requirements are, because things like multi-cluster, etc. Honestly, I hadn't heard about them before.
Yeah, we've been discussing about it for a while, Nicholas. Um, it's a simple use case, but yeah, I wasn't capturing any of that in the diagram, but yeah, we can definitely clarify all of these things, and let's start with that. Let's start with defining, like Ben said, why do we even need this change? Um, is the current mechanism okay or not? And we'll go from there.
Thank you.
Yep, thank you.